Hi, grade 11s. I'm back doing the questions again. This time for 7.2, the limiting reactant questions. And I know these ones are difficult. And they can be found on page 254, number 25, 28, and 30. And I'm sorry that I feel so monotone and boring. It's this quarantine, this lockdown, whatever you want to call it. I think it's finally getting to the best of me. So I hope you guys are okay. I know how much stress you guys are under, and I'm very proud of everybody going through all this and learning chemistry. Okay, so acrylic, so I'm working on number 25. Acrylic, a common synthetic fiber, is formed from acrylonitrile. Acrylonitrile can be prepared by the reaction of propylene with nitric oxide. And so let's look at what's going on. So we have a hydrocarbon. Isn't it weird to think that a lot of our synthetic fibers that we wear, oops, that's for my grade 12s, those backward arrows, but a lot of it comes from fossil fuels. And so you can see, I'm sure some of us have acrylic clothes. I hate acrylic clothes. It makes it's not very breathable, but hey, they're cheap. Okay, so it does come from a type of hydrocarbon, propylene, with nitrous oxide, and then it forms acrylonitrile. God, I can't say that word. So what is the limiting reactant when 126, so I'm going to set up my mass, molar mass, number of moles, and my xn, right? And what is the limiting factor when 126 grams of propylene reacts with 175 grams of nitrous oxide? So let's start calculating molar mass. 3 times 12.01 plus 6.06. I get a molar mass for propylene of 42.09 grams per mole. And for nitrous oxide, I get 30.01 grams per mole. And I hope you guys don't mind the table. I know some people hate it, but it really does save just so much time. Okay, so since we're moving down the table, we're going to divide. And I get 2.9935. I'm not going to round yet. Oops, except for that 5. I'm going to round to 6. And then I'm going to do another step here. I'm going to divide by 4 because of my coefficient here of 4. So divide by 4 and I get 0.7484. Okay, 175 divided by 30.01 is 5.8314. I'm going to divide here by 6. And I get 0.9719 moles. This is now where we get to look at who is the limiting reactant. So in this case, who has less? This final step, well, you can see that this number, once you account for coefficients and everything, that is less than the other number. So that is my limiting reactant, which is propylene. Therefore, propylene is the limiting reactant. There's just less. Once you account for how many moles there are and the ratio of moles that you need for each reaction, you need 4 propylenes and 6 nitrous oxides. The number that you get once you account for it is less than the number that you get for nitrous oxide. So this is how you do the format to find a limiting reactant. Okay, number 28. And if there is a unit, if there is a section of this course that is the most important for grade 12, it's this. You cannot go into grade 12 not understanding stoichiometry. You cannot go into grade 12 not understanding ratios, limiting reactant, excess reactant, being able to do these calculations. So if you have to watch this video 5 times, watch it 5 times to understand, okay? Just make sure that you have a good grasp of this once we move on. Okay, so 28, hydrazine reacts exothermically with hydrogen peroxide. So remember, exothermically, it's going to produce heat. So 120 grams of hydrazine reacts with an equal mass of hydrogen peroxide, which is the limiting reactant. Okay, so let's set up our table. N2H4. Oops, it's a liquid plus, oh gosh, no, it's a Friday. So it's going to react and form, do you guys remember what this is called? Nitric acid and dihydrogen monoxide, water. So we're going to do mass, molar mass, number of moles, and then we're going to account for the coefficient. So we have 120 grams of both of them. But look, ooh, we have coefficient 7 in front of hydrogen peroxide. That's going to mean that there's going to be a lot less available. So let's calculate the molar mass of hydrazine. And I get 32.06 grams per mole. And for, let's do 120 divided by 32.06 right away, I get 3.7430 moles. And there's no coefficient, well, coefficient 1, so we do not have to account for a coefficient that is not 1. Okay, 2.02 plus 32, I get a molar mass of 34.02 grams per mole for hydrogen peroxide. 120 divided by that is 3.527, 3 moles. And look, over here, hydrogen peroxide is still going to be the limiting reactant. There's way less moles of it to go around, but then once you account for the fact that you need 7 of them, you get these two numbers, and since this is 0.5040 moles is much less, therefore H2O2 is the limiting reactant. Okay, now it's asking for, in B, I'm going to do all my B colors in blue, what mass of nitric acid is expected. So because this is the number that limits, I'm going to put this number here. Remember, we're going up, so I get to multiply. So I'm going to multiply that, and I get 1.0078 moles. And now I have to take the molar mass. So we have 3 oxygen plus nitrogen plus hydrogen, and I get 63.02. Multiply that by 1.0078, and I get 63 point, how many significant digits? I need 3 significant digits, so 63.5 grams. Therefore, 63.5 grams of nitric acid is produced. And then it says what mass in grams of the excess reactant remains at the end of this reaction. Okay, so this is, I think I had a few people ask me about this, and I was like, I need to show you guys. So what we have to do, using these two numbers, we have to figure out what the leftover is. So number of moles excess equals 3.7430 moles times minus 0.5040 moles, because I need to figure out how much wasn't reacted. So it's 3.239 moles that are left unreacted. And you have to make sure that you're using these numbers, because every 1 mole of N2H4 reacts with 7 hydrogen peroxide. So you can only use the one that accounts for the coefficients. So now that I have the number of moles left excess, was there a coefficient in front of it? No, the coefficient is 1. If I had to divide, if I had to divide the coefficient when I'm trying to find out how much mass is left over, I'd multiply by the coefficient. But the coefficient is, it hasn't changed, it's 1. Okay, so now the mass of N2H4 is going to be 3.239 moles, and I'm multiplying by the molar mass. So multiply by 32.06, and I get 104 grams. So only 16 grams of the hydrazine was reacted, and that is because, remember I said, ooh, big number coefficient there. There's just way more hydrazine molecules compared to hydrogen peroxide when it's a 1:7 ratio, and so only 16 grams got used up. And then I think I'm getting you to do 30. I'm going to let you guys do 30 on your own, because it's pretty much exactly the same as 28, and I know you guys are more than capable of doing it. Okay, let me know how that goes, and hopefully you don't say terribly, but it's okay if it does go terribly. Just try doing a couple more practice questions and going through these on your own. Okay, good luck.